So guys, today we are going to start our Numpy. So from today we are starting our data science journey, and the first thing we are studying is Numpy. So first of all, we will talk arrays versus Numpy and why Numpy is considered over the list of Python. Okay, so the main thing is the data types of the Python is very slow. That is, the list is very slow, and NumPy has a very speed of execution. So that is the main thing we use NumPy, and let's study this as well. What is NumPy? NumPy is the fundamental package for scientific computing in Python. So by using NumPy, we can we can do many mathematical calculations and uh, many mathematical formulas and plotting the graphs and many things. So the main advantage of this NumPy is the array object. Okay, so it is a Python library that provides multi-dimensional array object, various derived objects such as masked arrays and matrices, and an assortment of routines for fast operation on arrays, including mathematical, logical, shape manipulation, sorting, selecting, input-output, discrete Fourier transfer, basic linear algebra, statistical operations, and random simulation and training. So all of this we will study later. And the main thing is the execution speed. Okay, it has very high execution speed. At the core of NumPy package is the ND array object. So that is the NumPy array. So NumPy has its own array object, that is NumPy array, and it has a very high speed of execution. Okay. So the main thing is it has a very high speed of execution. One second. Okay. And then uh, let's compare NumPy arrays with Python sequences. So NumPy arrays have a fixed size at creation, unlike Python list. So it has the uh, fixed size, that is, we declare that size initially, and that is the size we will be using. Uh, but in list, it has the dynamic size, and it can take any type of size according to the input, and it grows dynamically. We can say that, and the changing of size of an ND array. ND array means numpy array. Okay, so we'll create a new array and delete the original. The elements in the numpy array are all required to be of same data type. So it is the same as the arrays in C and C++, which can only hold the elements of the same data type only. Like the integer type of array can only hold the elements of integers, and character type array can only store the characters only. So that is the thing here as well. So the NumPy array is coded in C language. Okay, so it is coded in C language, which gives us the maximum speed for execution. So while calculating lots of data, right? So we can have GBs of data, right? Gigabytes of data. So that size of data is very hard to compute. That takes a lot of time to compute basically. So the Python list will take a lot of time, but this NumPy array is very, very fast because it is internally coded in C language. So that is why we are using NumPy array over list of Python. Okay. So then those will be same size in memory. The elements in NumPy array all required to be the same data type, so they will be have same size. All the elements will take the same size, okay, because they are of same data type. So we know that the list in Python can store many data types that can be Boolean or any float, integer, character, string, anything. So it can store anything because it it is also known as the referential array, and it stores the address of the those stored elements. So while executing any calculation in the list, it will first of all search for that address and will extract the value from that address. So which takes a lot of time. So that searching and extracting thing takes a lot of time, although it is dynamic and it is very useful in doing normal calculations, but in doing this data analysis in GBs of calculation, that is a very huge data. NumPy array is very, very potent in that. Okay, it is very useful and significant impact it can create, and it is facilitated advanced mathematical and other types of operations on large number of data. This I have already explained that we can uh, we can do the large operations using NumPy arrays. So typically, such operations are executed more efficiently and with less code than in possible using Python inbuilt functions. The growing plethora of scientific and mathematical Python-based packages are using NumPy arrays. Through this typically support Python sequence input. They convert such input into NumPy arrays prior to processing, and they often output NumPy arrays. So NumPy arrays has a great use. That is the thing we need to remember. Okay, so it has a very high speed of calculation. That is the main thing we can remember. And then the another thing is it can also we can also change the data type. Okay, we can also change the data type of the element inside of that, stored inside of that. So we can use integer 32, integer 16, integer 8, and the default is integer 64, which takes 8 byte. One element takes 8 byte. Okay, so if we are doing calculation in a very small values like only 100, like our values are only taking up to 100. For example, we are storing age of a person of a lot of people in a country, let's say. So we are analyzing the age of the people in a country. So what can be the maximum age of a person? That can be 100 or 120s. So it cannot exceed more than that. So we don't need integer 64 type of uh, data type. Okay, so we can do that in I think integer 8 or 16. So we don't need more than that. So using that kind of data type, which is small, and we can use optimize our storage. Okay, so it is very storage efficient, and it doesn't take much more storage than necessary. Let's see how to create the numpy arrays. So to create numpy arrays, we can see for 1D arrays, we can just use np.array. So we have imported, first of all, we need to import our numpy as np. So, and we can just use that is np is our object name. So object dot, we have many methods and functions inside np already built by these developers. So we can just use them by remembering these functions, or we can say methods. So mainly we to create the numpy arrays, we can use just np.array function, that is small bracket, and we can pass a list inside of that small bracket, that is big bracket, and the numbers or elements, we can say. So the default data type of the elements is float. Okay, that is a float. Float is the default data type in the numpy array. And we can see I have printed the type as well here. So let me run this, and we will talk about it. So get us terminals. Okay. Okay. So you can see this is the array. This is the numpy array, and we can see the type of that array is numpy dot nd array. Okay. So the type that we have created this array as numpy type. So numpy array is different and it has high speed. Just remember this thing. And uh, this is the method of creating 2D array and similarly 3D array. So similarly, we can just pass the 2D list, 3D list to create the 2D and 3D array manually. Okay. So D type means data type. So we can also fix the data type of the elements inside of that numpy array. Okay. So for that, we can just use D type. Okay. So after giving the elements inside of that array, we can just use comma and d type equal to float or any integer or anything. Okay, int or float, we can use that to specify the data type of the element inside of the array. Okay, so then we have a range function as well here in the numpy as well. So it is same to same. It is same to same, similar as the range function in normal Python. So the thing is, here is a range. Okay, a range. So we have to just type np dot range from here to here. Okay, so the first one is included, that is this one is included, but 11 is not included. That means it will print up to only 10. Okay, so we can see here, I think this is the one. You can see up to 10 it is printed. So that is the thing. And then after range we can see the reshape. So the reshape function is very uh, important. Okay, we can cast any elements into the any order of matrix. So let us assume that we have a 1D matrix. Okay, we have 1D matrix and it has 10 elements, let's say. We can cast it to any order of matrix which will have the same number of elements. For example, we have 10 elements. That means we can cast it to any 5 into 2, 2 into 5. So in that way we can do that. Okay, so my battery is almost 19%. I think it will keep up with me. And then we have dot reshape, right? Dot reshape function can be used to reshape any size, reshape the order of the matrix. So dot reshape will reshape the order of the matrix into any type, any order we want. So we will pass the order inside of these brackets. Okay. So and then initialize array with one. So we want to create an array which will have all the elements one. Okay. So for that we will use np dot ones and we will give the order of the matrix. So you can see here this is the one. Okay, so I have given 3 comma 3, so it has printed 111 and you can see dot, that is the default data type, that is float. Okay, and then initialize array with zeros. So we can do the same by by initializing it with 0 as well. So it will create the matrix with all the elements as zeros. So you can see all the elements are zeros. So that is np dot zeros, np dot ones and np dot zeros. So that is it. And then and we can also initialize it with random number, and it can be initialized with random number is our choice. That is from here to here, these many words. Okay, from here to here, and we will give the number of words. Sorry, number of elements. We want to randomly create inside of the list. Sorry, not list, array. So here you can see, first of all, that is random dot random, np dot random, and passing the order of the matrix will create uh, a matrix with random numbers which will range from 0 to 1 only. Okay, so it will create a lot of members, that is elements, which will have decimal uh, that will have decimal type of element, right? Because we have float type default data type, so it will create in you can see that kind of elements we will get when we use np.random.random function. Okay, so this is the order of the function, and remember that you will uh, pass the order in small brackets. Okay, so that is, you cannot do like this. Okay, so this thing you have to remember. You cannot directly put the pass the order of the matrix, but you have to separately put one small bracket inside of the function bracket. Okay, function bracket. Then you can see the mean space. Okay, one more random. Uh, yeah, so Add this as well. Np dot random dot rand int is here. So we will pass from 1 to 10, not 10. Let's say 20. I need 10 elements. So that is from 1 to 10, 20, 10 elements. Any random elements, it will pick, sorry, this is not you. This will pick any random elements from 1 to 10, from the range of 1 to, sorry, 21 to 20. I think 20 is not included in this. That means it can pick up any number between 1 to 19. 19 is also included. Any 10 numbers. This is the number of any elements. Okay. So I want to print this thing. Error of 7. Okay, let's see what is printed. Is it already printed or what? I think, which one is that? Hmm, is this the one? 10 elements. Random. It should be after the random. This is the random. So this is the one. Okay. So this is the one. So it is creating, it is picking 10 random elements between 1 to 20. Okay. 20 is not included, 1 to 20. Only 10 elements it picks up randomly and makes a 1D array from it. So you can see 1D array is created by using this. And then linspace is here. So it is used to create uh, equidistant elements. That is equidistant values of the numbers that is inserted inside of the array. So we can simply do np dot linspace function, that is brackets and starting and ending point and number of elements. So um, it will pick, it will divide the numbers between 1 to 20 into 8 equal elements. That is 8 equal numbers. Okay. So it will divide 1 to 20 into 8 pieces. Okay. And that points will be considered as the element inside of this array. Okay. So that is it. You can see that thing here. So from 20 to 1 to 20, it has uh, slice, we can say it has divided the um, numbers into 8 equal parts. So if you subtract this from this and this from this, you will get the same answer. That is, it is basically in arithmetic progression. We can say that this create the list of 8 numbers from 1 to 10 with equal difference. That is AP. So I have also written this thing. And here is another function that is to create identity matrix. Okay, so let me see if it is recording or not. It's recording, okay. To create identity matrix, we can just use np.identity. Okay, so we can just use np.identity to create identity matrix, and inside of the brackets, we can just uh, specify one number, and it will create the same number of rows and columns. Sorry, same number of rows and same number of columns. It will create some identity matrix with main diagonal 1 1 1. Okay, so that is it. You can see I had given 3 as the number inside of these brackets, and I had also specified the data type. So it has created in integer data type. Otherwise, it will create a default on float data type. Okay, so and then to find the dimension of the numpy array, so to find the dimension, that is it is whether it is 1D array or 2D array or 3D array, we can use ndim. Okay, that is arr dot array dot ndim. Okay, that is array dot ndim. Again, to find the order of the matrix, we will use array dot shape. Okay, so to find the dimension, ndim shape, uh, shape, to find the order, we will use shape, and to find the number of elements, we will use size. Okay, so we have to remember this thing. It's not so useful, but it's okay to remember. Okay, we can sometimes check whether the two matrices have same order or not. same number of elements or not. We can just check this thing. So it can be useful. That is NDIM for dimension and shape for order and size for number of elements. And then item size for each number of element. That is the size of one element that is taking. The storage it's taking. Okay. So you can see, I think I have typecasted something else there. Let's see. So this item size will the default item the default is int 64, which will take 8 bytes, and int 32 takes 4 bytes. Okay. So normally in C language, we say that integer takes 4 byte of space in array, or whatever data type it is. So integer takes 4 byte of 4 byte of storage. In case of C and C++, we say that, but here we say, let me connect my charger. Just a second. Where is the point? Okay. Okay, it's connected. So, but here it takes 8 bytes of uh, storage. Okay. So that is it. And then to know the data type of the elements inside the array. So what type of data type we have inserted inside of our array, the data type of the elements inside of the array. So we can do that by using d type. Okay, arr dot d type. That is array name dot d type. Array name dot ndim for dimension to check the array whether it is 1D, 2D or 3D, and arr dot shape to check the shape, sorry, order of the matrix, and shape, and then size for array dot size for to find the number of elements of the matrix, and then mm, then what was it, item size, then item size to find one, the size, the storage, it one element taking inside of the array. Okay, so that is it. And then after this, I think this, we are just here. Oh my god, I should cover more fast. So I have already told the receipt. So let's see the operations of array that we can do using NumPy. So in the NumPy array, we can do arithmetic operations. So we have one array, let's say 2D array, and that is ARR. If we do ARR plus 2 here, okay. So if we do ARR plus 2 here, it will add 2 into all the elements of the array. Okay. And if we do asterisk 2, that will multiply all the elements of the array with 2. So, and then if I do double asterisk 2, then it will generate the square of all the elements of the array. And then I can obviously do division as well. So these are the scalar operations. So and then we have relational operators. This returns the boolean value. Okay, so if we are comparing the array with any number, or so we generally compare with numbers. So if I comparing the array with any number, then the all the array elements are compared with that specific number, and if the condition is satisfied, if that comparison condition is satisfied, then it will return true, otherwise it will return false, and it is um, it is displayed in the form of matrix of same order. Okay, so we can see that thing here as well, I think so. Let's see. Oh my god, what did I press? Sorry. F5, Python before. Okay, I think, where is true false? Okay, you can see here. Uh, this is the first one for this. Okay, so in this way, it will return true or false. That is Boolean expression. That is Boolean result, we can say, in the form of matrix. So we will use that Boolean slicing afterward. So this Boolean is very useful to us. We will see that And then we can also do vector operations. Okay, so vector operations, it is more accurate to tell this is tensor operation rather than vector operation, because it is not actually the vector, it is tensor. So that means, what is tensor addition? Let's see the addition first. So I have one array that is array 1, ARR1, and I have another array that is array 2. Okay, ARR2. So if I do ARR1 plus ARR2, then it will do what? It will add the corresponding elements of the array. Okay, so that is the same position of the arrays are the same position of the elements are added. Okay, same way it is subtracted in the same positions, that is corresponding elements, and multiplication is also done by same corresponding elements. So this is not the matrix multiplication. Okay, so matrix multiplication we have other function. So this is not matrix multiplication. We are just multiplying the corresponding elements of two arrays, that is array 1, ARR1, and ARR2. And then we have power. We can also do to the power of another array, that is two arrays are I think corresponding element goes to the power of the another element. So that is it. And then let's see the array functions. So so similarly, same as in the list and tuples that we have seen, it also has some common functions, that is sum, min, max, and it also has prod, that is product. So np dot sum function array. So if I use np.sum and pass the array, it will give the sum of all the elements that is present inside of the array. And np.max and pass array, that will give me what? That will give me the maximum value. Similarly, np.min and np.product, this np.prod and ARR inside of the bracket will give me what? It will give me the product of all the elements inside of the array. Okay, so that is it. And to find the maximum value, a maximum and minimum value in a specific row or a specific column, we can do, okay, we can do that np.max, np.max, and we will pass ARR inside of the bracket, and we will give comma, and then we write axis equal to 0 for column and axis is equal to 1 for row. So it will return all the values. So all the maximum values in the row in case of x is equal to 1, and it will return the maximum values in all the columns. So column 0, column 1, column 2, column 3, it will return all the maximum values in each column when we use x is equal to 0. So x is equal to 1 is for row. Okay. In case of np.max or np.min, or I think it can be used for other thing as well, that is variance or standard deviations and other functions also we have. You can see here, that is mean, median, standard deviation, variance. So you can use for these things as well. So that is axis equal to 0 means row. Sorry, this is the row, and axis equal to 0 means column. Axis equal to 1 means row. Axis equal to 0 means column. Okay, that is it. So we can use np.sum, np.max, np.min, np.prod, and I think, and then we can give a comma after passing the array name, and then comma, and we can use axis equal to 0 or 1 for finding the specific either for row or column. That is it. And I have already told np.min will calculate the mean, np.median will calculate median, np.standard deviation, that is STD, and then np.var means variance. That is it. And then for trigonometric function as well, we can just use np.sin, cos, tan. I think everything is supported. And this is the main thing I was waiting for. That is dot product of the matrix. So for the dot product of the matrix, that is multiplication of two different matrix. Okay, I'm not talking about the multiplication that we have already talked about. That is the multiplication of the elements, that is corresponding elements. That is not the matrix multiplication. So in this matrix multiplication, it is mainly referred as dot product. Okay, so it is referred as dot product, and it is very different. Okay, so it is very different. Uh, Basically, we say that the corresponding elements of the the corresponding rows element of the first matrix and corresponding column elements of the second matrix are multiplied, and added to get one element of the result matrix. So that is it basically. So this we can do by using very easy function, that is dot. So we will easily use np dot, that is np full stop and dot, and we will pass two arrays, that is array 1 comma array 2. So that will give me the dot product between two arrays. So it is very easy. Okay, and we can also use log and exponent function similarly, that is np dot log for log function, np dot exp for exponential function. So that is it. And we have some rounding of type of functions, that is np dot floor for um, rounding the float number into floor. Okay, so if I have 6.8, then it will round off it to the floor value. Okay, not the ceiling value, it will round off to downward value. So if it is 6.8, then it will round off to the 6. Okay, that is the floor value. And if I use np.ceil, that is ceil, seal, then it will round off to the above value. If if even I have 5.2, then it will round off to the higher value. That is seal means higher, ceiling. Ceiling and floor we can relate it like this. In the house, ceiling is the upper one, floor is the lower one. So if I use floor, then even if it is more than zero point 0.5, okay, even if it is more than zero point 0.5, np dot floor will decrease it to the lower value. Okay, that is 6.8 is also considered as, it will also converted as 6. And then if I use seal, then 6.2 is considered as 6. Okay, so that is it. Hmm. Okay, sorry, 7. 6.2 is considered as 7 if I use seal. And round, we also have a round function that will round off the value, that is the most genuine one. Okay, so if it is more than zero point 0.5, then it will round up to the upper value. If it is lower than zero point 0.5, then it will round up to the lower value. So that is the much more genuine roundup. Okay, so the reshape we have already talked about this. So if we have array of some number of elements, then that number of elements can be converted into any order of the matrix. So that is by using dot reshape function. Okay, this I have already talked about it. Mm, and then the transpose function. So this is very easy. That is np dot transpose, and then we will pass array inside of the function. So np dot transpose function. Okay, and it also has a shortcut, that is array dot t. Okay, array dot capital T. It will automatically transpose the function. That is it. And then we have rabel function. So this will do what? This will convert any 2D or 3D matrix into 1D matrix. Okay, so it will extract all the elements and convert it into 1D matrix. So we can see, I think, here, uh, let me run this again. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So before it was like this, I think it was 1D or 2D matrix. Sorry, 2D or 3D. It was, I think, 2D matrix. Okay, so it was, first of all, it was 2D matrix. 5,3. Okay, we can see this thing. You can see, I think this list is not in use anywhere. So I have used arrange function dot receive to make this array. So I have converted this into 1D array by using dot ravel function. Okay, dot ravel ravel to convert any 2D or 3D function into 1D. Sorry, to convert any 2D or 3D array into 1D array, we can use dot ravel ravel function. Okay, so for changing the data type, we can use its type function. That is, you can see I have created one array that is arr1 equal to array dot arr dot its type, and we will pass np dot int 32. So if we do this, we can change the data type of the function, sorry, elements, and we can optimize our storage. So if we are dealing with lower numbers, that is lower value numbers, then we can just use 32 int 32 or int 66, sorry 16 to save our storage. That is it. And then indexing and slicing. So indexing and slicing in 1D array is same to same as in the list and tuples. I think not in the tuples, it is in the table. In list, okay, same as in list. So you can see, and inside of the 2D array, it is little different in case of numpy arrays. So you have to use big brackets and 1 comma 2. That is a comma b in the form of, you have to write in the form of a comma b. So in the case of C and C++, we used to write like this way, right? A, and then another inside of the another big bracket we used to give b. So this is not the case here. Okay, so we will give in the form of coordinates, that is not inside of the small brackets, but still in the form of comma. Okay, so 1 comma 2, 2 comma 3, like that in case of 2D array. And for 3D array we will use three elements, of course, three uh, different values and separated by commas. So 1 comma 2 comma 2, you can see here 1 comma 2 comma 2, and then 0 comma 1 comma 2. So in this way, I can do indexing of the 3D arrays as well. So in case of slicing of 1D array, it is the same. It is the same as in the list. Okay. So in case of 1D array, the slicing and indexing is did to same. Okay, but in the 2D array it is little different, so we need to understand that thing. Okay, so we just have to understand the uh, format, that is for example 0 colon 1 colon 1 comma, then 0 colon 1 colon 1. So what does this thing means? So we need to understand these three things, that is some value clone, some value clone, some value. Okay, these three values, what are these things? So this is for row and this is for column in case of 2D matrix. Okay, in case of 2D array or 2D matrix, we can say that the first one is for uh, row and second one is for column. So it says like we can depict it as from zeroth column, sorry, zeroth row to one row. That is one is not included obviously. So this second value is not included. That means if I add return 2 here, that means it will mean that the row is from that row that is included is 0 and 1. Okay, 2 is not included here. So from 0th row to 1st row, including 1 as well, having a space of 1. So this is the space. Okay, so space of 1 means none of the row is skipped. Okay, if I use skip here 1 in place of 1, if I use 2, then it will skip one row. Okay, it will skip one row. So the first row is printed, and then the second row is skipped, and then third row is printed. So if I used 2 in case in instead of 1 here, then one next row is skipped. And then after this comma, this is for column, and the thing is same, starting column number, ending column number, and the space. Okay, if I use 1 in the case in space, then it will not skip any of the column. If I use 2, then it will skip the next one after the first one that I have included here. After 0th column, it will skip the next column. If I use 2, if I use 3, then it will skip 2 next column. Okay, then it will jump to the third fourth column, we can say, that is third index of column. So in this way, we can use slicing of 2D arrays. So for slicing of 2D arrays and 3D arrays are the same thing. Okay. So if we understand the slicing in 2D arrays, then that is similar in 3D arrays as well. So you can see if I want to only extract the row of a 2D array, then I will just use this thing. Okay. So I will specify the row. Okay, row number. In case of indexing, obviously that is zeroth row means first row. Okay, zero and comma and colon. That means the first row is extracted. If I use three comma double, that means colon. That means fourth row is, or in case of indexing, third row is extracted. Okay. So similarly, in case of column, if I want to extract third column, then what will I do? Then I will do uh, colon comma 2. Okay. In case of indexing, the third column is 2. So we can do that thing. And I have done some of the questions here, so I don't think I need to do all of this now. In case of 3D arrays, it's the same thing. Okay, so I just have to remember that A colon B colon C. A means starting point, B means ending point, but B is not included. Okay, B minus 1 is included. B is not included, and C is the increment. Okay, C is the increment. And then in case of 3D matrix, it will be the first one will be for Z, second one will be for row, third one will be for column. Okay, so that is it. So mm, you can see here, this is for Z, this is for row, and this is for column. Okay, so that is it. So let me run this and see something. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2D array, okay. In case of 3D array, I can see this is my whole 3D array, okay. I have three 2D arrays, three 2D arrays. So that 3 means 0, 1, 2. I will say that is Z, okay. 0, 1, 2. So I have three 2D arrays. This is first, this is second, and this is third. I have three 2D arrays. So 3D arrays is composed of many 2D arrays, right? So I have three 2D arrays here. So the first 2D array will have Z value of 0. The second 2D array will have Z value of 1. The third 2D array will have Z value of 2. So I will specify it like that. And if I want to print the middle column of the second 2D matrix, so if I want to print this one, this 15, 17, and 67, then what will I have to do? First of all, I will have to specify the ABC of the Z. Okay, ABC of the Z. So what is the Z of this column? What will be the Z? It will be 1, obviously. And the Z value for first one is 0, second one is 1, third one is 2. So this will have Z value of 1. Okay. And then 1 will be the starting point. Then only this 2D array is included. So we don't need to include other 2D arrays. So it will start from 1 and we will give colon and we will write 2. That means only 1 is included. Okay, that means only 1 is included, and we can also give colon and increment equal to 1. So it will have no value. We can just write only 1 here. Okay, So 1 colon 2 colon 1, and just simply we can write only 1 and then comma. So our Z is finished. Then we have to just look up after this one, only this 2D array. So now we have to only extract this middle column. Okay. So for that we can just use uh, only colon, comma, and one. So that is it. We can just use that. But still, if we want to do with proper order, then we can follow the order as well. For that, we can just use the column number. First of all, row number. Row number is not specified. We can just take all the rows. That is from uh, 15, 17, 67. We'll have all the row of the this this 2D matrix. It will have all the row, that is zeroth row, 1st row, and second row. So we can just say from 0 to 3 increment of 1. We can specify like that. And then comma, and it's the tone for column. So column will be what? Column will be the middle column. That will be 1. From 1 to 2 we can say, because only the middle column is included. So if I write 2, then that means from 1 to 1 basically, because 2 is not included, and I will give increment of 1, or otherwise I can just simply write comma 1 only. Okay, so that is it. 1 comma 1 comma 1, we can directly, I think, 1 comma colon comma 1, that should be enough, I think. And you can see this way it is extracted, and that is it about indexing and slicing. So let's see how does loop works in array. So we know that for I in array, print I, we have used this thing, that is iterable property of loop, or any sequences. We have used this in many sequences. So what if we use this in this array? So in case of 1D array, it will be normal. It will iterate over all the elements of the 1D array, and it will print all the elements of the 1D array. So that will be no problem. So in case of 2D array, it will show a different characteristic. So in case of 2D array, it will print the arrays in in rows. Okay. So if it is 1, 2, 3, 4, 5, 6, 7, 8, 9, then it will print like, first of all, 1, 2, 3 is one array, single array, and then 2, 3, 4, sorry, 1, 2, 3, 4, 5, 6 is another 1D array, and third 1D array will be 7, 8, 9. Okay. So in this way it will print. And in case of 3D array, it will print the elements as the 2D array. So I think that would be no difference in case of 3D array. So printing the array and printing by using iteration, it will have no difference in case of 3D array. But in case of 2D array, it will convert each of the row into 1D array, and it will print each row as first array, and another row as second array, another row as third array. So in this type, okay, you can see this is the first row, I think, and this is the second row, or this is the third row. In this type, it will print. So that is it. And then or otherwise we can say it doesn't affect anything, and we can iterate over all of the elements, whatever dimension it has. We don't care about the dimension this time. Whatever dimension it has, we can iterate over the all of the element. We can go to the all of the element. We can pick all of the elements separately and print out that each element. Okay. So for that we have to use one function, that is np dot diter, sorry, nd iter. Okay, nd iter. Okay, so sorry, np dot nd iter, np dot nd iter, and we will pass array. So so this function will help us do that, to iterate over all the members. Okay, so then we have uh stacking, that is, we have horizontal stacking and vertical stacking. So stacking means to join two arrays. Okay, so we have one matrix, that is arr1, to another matrix that is ARR2. Okay, so if we want to join that array like this, okay, then that is known as horizontal join. That is horizontal stack. And if I join it like this is my array one and this is my array two, if I join it like this, then it will be vertical stack. Okay, so if I have one, two, three, okay, one, two, three, one, two, three. So this is my array one, and I have 4, 5, 6, 4, 5, 6, and 4, 5, 6 as another array that is array 2. If I do horizontal stacking, then it will join like this. And now the elements will be like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And then if I join vertical stacking, if I do vertical stacking, then it will be like 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 4, 5, 6, 4, 5, 6, 4, 5, 6. Okay, so that is it. So for that, to do horizontal stacking, we can just use np.hstack. To do vertical stacking, we can do np.vstack. Okay, so that is it in this. So cutting, let's say cutting, let's see how do we cut some array. So it is actually the splitting of the array into n equal parts. Okay, so for that we use horizontal splitting and vertical splitting. So this is the horizontal splitting. Okay, so if I cut in such a way so that it splits horizontally. Okay, if it splits horizontally, then it is horizontal splitting. If I cut in such a way so that it splits vertically, then it is vertical splitting. Okay, so if I have one array, let's say that is 1, 2, 3, and 4. Let's say I have this array. Okay, so if I do vertical splitting, it will be splitted like in this way. Okay, and then this 1, 2 will be splitted and made one matrix, and 3, 4 will be splitted and made one matrix. Okay, it will be splitted in this way. And if I do horizontal splitting, then this 1, 3 will be one matrix created, while 2, 4 will be one matrix created. This is the horizontal split. Okay, so that is it. And so mm H split and NP dot V split. So NP dot H split and NP dot V split. NP dot H split and NP dot V split. The stacking and splitting are have the same uh, syntax. Okay, so it has similar syntax. We can say that is NP dot H stack and V stack. It also has NP dot H split and V split. Okay, so that is it. Then we will see the fancy slicing and Boolean slicing. So let's see first the fancy slicing. So we have already seen the slicing, and if we have some specific mm, some specific progression, or we can say it has some specific order to extract the elements. So if we are given some specific order to extract the elements, then we can simply do by the method that we have already seen. But if we are given some uh, random rows, let's say some random rows to extract like 1 and 3 and 4 and then 6 and 7 like that. So if we are given like that, then we can directly specify the column number or row number to extract that column or row. Okay, so in that case we will mm, study under fancy slicing. Okay, so that can be done by using fancy slicing. So we will just do the same thing, but we will pass a list. Okay, so if I want to extract that is having index number, if I want to extract a row having index of 1, 0, 1, okay, 1, 3, 1, 3, and 4. So if I want to extract these three rows, then I will just pass these rows into a list. Okay. So in this way, you can see inside of the list, I will pass this rows position and I will put comma and then double colon to just not include all the columns, to include all the columns, we can say. Um, that is it. To extract the rows and to extract the column, we can simply do the same way. That is colon, comma, and then the columns number. And we can also do this for, I think we can do the combination of this fancy slicing and the normal slicing to extract any element. I think we can do that thing. I think so, but it takes some processing, I think. And then Boolean slicing. So this is very, very nice concept, and I think it will be used in future very much. So let's see this more detailedly. Okay, so that is Boolean slicing. So we already know the Boolean expression that will return the value of either true or false. So so we use the Boolean expression inside of the slicing expression. Okay, so we will use what Boolean expression inside of that slicing expression to use this Boolean slicing. So so this will return what? This will return those elements which will have the Boolean expression, Boolean result of value true for that specific Boolean expression that we have passed inside of that slicing expression. Okay. So that is the thing. Am I clear on this or not? I think I'm clear. So let's see this code by running it. So we need to observe this thing. So I have created one array from random integers from 1 to 11, that is up to 10 of 10, that is okay. And I have reshaped it into 5 comma 2 order. Then um, I have compared it with a Boolean expression. So print, and I have passed a Boolean expression inside of the print function. So it will return what? It will return the array. Okay, it will return the array. It will compare all the elements of the array um, with value 2. And if the element is greater than 2, and it will um, return true as a Boolean result, and if it is false, then it is return false. So we can see true and false. The combination of true and false is returned by this Boolean expression. So we can use this inside of this slicing expression to extract that element which will have the Boolean result true for that Boolean expression. So whichever element is greater than 1, I want, sorry, greater than 2, I want to print those elements, then I can just pass that Boolean expression. That means the elements of the arrays greater than 2 inside of that slicing expression. So inside of that slicing expression, I can just pass the Boolean expression uh, to extract those elements which satisfy the conditions. So whichever element will have, whichever uh, element satisfy that Boolean expression, it will have Boolean result true. So those true value, those elements which will have the true value will be extracted. Okay, will be extracted and printed over here. We can see this thing. Okay, so that is it about Boolean slicing. So we can compare it to whichever which of the following elements are divisible by 5, which of the elements are even and greater than 5. So we can use two different cases as well, but we have to remember that if we want to use and, then we have to use only one uh, ampersand, that is I think this one, only one ampersand, because for comparing two boolean, for using logical operators in Boolean expression, we don't use and or. Okay, so we don't use this thing, or we don't use this repeated double things as well. We only use one time. Okay, this and this. So this first one is for and second one is for. Sorry, or second one is for or. Okay, So that is it. And then let's see broadcasting. So if we have 2D element, one one we have one array we have, that is array one equal to that we have 2D matrix, let's say, and we have array 2 that is 1D matrix. So if I add this 2D matrix with 1D matrix, then what will I get? So in this case, the NumPy uses a technique that is known as broadcasting. So whichever matrix has a lower dimension, lower order, then it will be converted into the same dimension and order as of the higher order or higher dimension matrix. And then the calculation will occur and we will get the result. So in case of this thing, uh, so we have two rules. That is, the rule first is make the same dimension first. So we have to first make the same dimension, and second thing is we have to make the same order. Okay. So first of all, we will write if we want to find why how is the broadcasting occurring. Then first of all, we will need to write the order of the two matrices that we are adding or doing any calculation. So I think it is only applicable for adding. I think so. So, for adding, first of all, we need to identify the order of the matrix. Okay. So, if it is 1 comma 3 or 3 comma 1, then whenever we see that 1, okay, whenever see that 1 comma anything or anything comma 1, that 1 should be matched with the corresponding order of the another matrix to be added if it is higher. Okay. So, for example, it is 3 comma 1 matrix with plus 1 comma 3. Then first one has 1 in the column and second has the 1 in the row. So these two should be equivalent to each other. So we have to make both as 3 comma 3 because the one it has the first has the one in column, I think. So the second row, the second matrix has three in the column, so that should be same. So the row as well, that should be same. So if it is one, then we can make it. But for example, we cannot do this apply this broadcasting in case of different order of matrix like 2 comma 2 plus 4 comma 4 matrix, so we can't do that thing. Okay. I think in case of 2D plus 2D, in case of only one element, if it is added with only one element, then it can be broadcasted to any time. Okay. It can be broadcasted to any time. And if it is one row only, then that number of rows should have the same value as it is added with another matrix. Okay. So whatever matrix it is added with, it should have the same row as of that small 1D matrix. Okay. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9 is added with 4, 5, 6. So the number of row, or we can say number of column, that is same. Okay. Not the row, column, we can say. Or row is also fine. Okay. So if it is 4, 5, 6, or it is 4, 5, 6 in column as well. So that kind of matrix can be broadcasted and added. Okay. First of all, we need to make it the same dimension, and then we need to make it same order. That is it. So in making same order, we will repeat the same things. For example, if it is 1, 2, 3, we will repeat 1, 2, 3, 1, 2, 3 to make it 3 by 3 matrix. If it is like in this way, 1, 2, 3, am I 1, 2, 3? If it is like 1, 2, 3, then we will make it like 1, 2, 3, 1, 2, 3, and then 1, 2, 3. Okay, in this way. So I think I was not visible or something. Let's not care about that thing. And we can use many mathematical formulas in this numpy. Okay, so let me show you one thing. Import numpy as np. So I will define one function that is, so let's say whatever, and it is taking one array, let's say, and it returns the value as mm, we say some sign of np dot sign of array. We can use anything here. Okay, we will just use the mathematical that mathematical expression or any formula here, and we will make array equal to what? Array equal to which function do I have to use? Random dot randint list. Let's use this one. 10 any 10 elements. So I use this one and I will pass this to my function. So if I do this thing, then what happened, bro? Oh, sorry. I forgot to print. Mm, let's say it is stored inside of this array, and I don't see that. Okay, so we can see our array is printed here. Okay, so we have used this mathematical calculation here. So this is already the inbuilt function I have used here. But we can put any mathematical um, formula here and calculate like this using our Numpy array. The main thing is this mathematical calculation, whatever expression we write here is applied to every individual elements. So that is the main thing of Numpy array. Okay. So whatever formula we write, that is applied to every element of that array, and that value will be returned. Okay. So that is the main thing of using NumPy array. So now let's move to the last topic of this video, I think, that is plotting the graph. So it is very important, and we are using matplotlib for plotting the graph. So first of all, we need to import the matplotlib as matplotlib.pyplot as plt. Okay, so need to remember this, I think. And we are using linspace um, to generate the values of x, to generate the values of x. So we are plotting x and y, right? So we need to generate the value which are equidistant to each other. So that's why we are using linspace, and I am using range from -10 to 10, and I am generating 20 values here, and I am just plotting x is equal to y, and I created one more array that is y and assigned it the same values as of x, and I used plt.plot function, and I passed x and y inside of the function, and use this function plt.show because it doesn't show if I don't use this one. So the graph will be shown here. Okay, let's see. This is the graph. You can see x equal to y. This is the graph for x equal to y. And I have also created a graph for, I think, y equal to x square. Let's see this as well. So you can see that is the graph for x equal to y square. That is, sorry, y equal to x square. That is parabola. And then the last one, that is sine. Sine function. You can see the sine wave. So that is the way you can plot the graph. So that is it. I think I have finished with the NumPy basics at least. 1 hour, okay. And 8 minutes. That's good.